In this video, we're going to be solving systems of linear equations, meaning we've got some lines and we want to know where they cross. We're going to not be doing graphing today, but instead using a method called substitution. You could also use the technique of graphing by graphing the lines and seeing where they cross. But graphing these can sometimes be tricky, and they don't always cross in integer spots, which can make it even more challenging. So we're going to use the method called substitution today to get the same answers that you could get via graphing. Let's do one using the substitution technique. Your first job is to find one of the variables that you can get by itself easily. Sometimes there's more than one, but we're always going to be looking for one variable that we could get by itself pretty easily. In this first equation, I have this x that's almost by itself. If we could move this 2y over here, this x would be by itself. So that's my first step. I'm going to start by identifying this x is somebody I could get by itself. And then we're going to do that. So I'm going to take this x plus 2y equals 0 and rearrange it so that the x is by itself. I'm going to minus the 2y over. And we're going to get x equals, now 0 minus 2y is just minus 2y. Okay, so that is me just rearranging that first equation. Now, we know that x is the same thing as negative 2y. That's what that equal sign means. This x has the same value as negative 2 times y. We are going to use this and substitute it into this equation right here. So wherever we see an x, we're going to take this, what x is equal to, and put it in the x spot, because I know x is the same thing as negative 2y. So wherever we see an x, we can put negative 2y instead. So let's rewrite that, but instead of x, we're going to put negative 2y, because x and negative 2y are the same thing. But I'm going to keep the rest of this the same. And then we're going to try and solve this equation for y. So negative 2y and negative y is negative 3y. And then we could solve to get the y by itself. We're going to divide by negative 3. And I've got y equals negative 3. Now that we know that, we can take this and put it back in here to solve for x. So I'm going to rewrite this. X equals negative 2y. But instead of y, I'm going to use the value that I know y is. Y is negative 3, because we just solved that right over here. And then we should be able to solve for x over here. This is going to be x equals negative 2 times negative 3 is positive 6. So the coordinate point where these two lines intersect is at 6, negative 3. Remember, we're always x comma y. Let's walk through that one more time. Your first job is to find a letter that you can get by itself. And so that's what we did here. We got x by itself. X is the same thing as negative 2y. Now we're going to take that information and put it back into the other one that we haven't used yet. You can't put him back into where you started. You got to put him back in the other one. And in here, we're going to swap out x for what we know x is, which is negative 2y. So I've rewritten this, but instead of x, we put negative 2y, and then everybody else just stayed the same. We were then able to solve this equation to find y. Once you know one letter, you can plug it back in and find the other. Let's look at example 2. Our first step is to identify which variable we could get by itself. I think I have a couple options here. On this bottom one, this x, we could work with that. We could get this x by itself by moving this over here, and then we would have to divide everybody by negative 2, which would work just fine because negative 2 goes into both of those. I wouldn't want to do the y because I would have to divide everybody by 8, and that would give me some nasty fractions. It would work, I just don't want to do it that way. We could also use this top one. Now, I'm not dividing everybody by 16 because, again, nasty fractions. But we could divide everybody by 4, and that would work out okay. So you could use either of the x's here and not have too much trouble. You could do the y's, but you're going to get some nasty fractions. So I think I'm just going to use the first one and try and get this x by itself. So first things first, let's rewrite this and get x by itself. First up, I'm going to minus the 16y over to the other side. So we're going to have 4x equals, now those aren't like terms, so we can't put them together. And then divide by 4. Make sure you're dividing everybody by 4. And there is that guy all rearranged for x by itself. So we are saying when we write that x is the same thing as negative 4y plus 4, which means wherever you see an x over here, we could put this in the same spot. So let's rewrite that second equation, but instead of x, we're going to put in negative 4y plus 4. Now, you've got to be careful here. This is negative 2 times x, so it's now times negative 4y plus 4 minus my 8y equals negative 6. That's me rewriting this, but instead of my x, I'm putting in what we know x is equal to. Now we've got to get rid of those grouping symbols by distributing. That's going to be 8y minus 8 minus 8y equals negative 6. I've got some like terms here we could put together, but 8y minus 8y is no more y's. That's 0 y's. So those go away. And we're left with negative 8 equals negative 6. Now you and I both know that's not true. Negative 8 does not equal negative 6. That means this one has no real solutions. It also tells me that if we were to graph these two lines, we would see that they're parallel and never cross. Let's try one more. First step, get one of the variables by itself. So this one means we're going to have to divide everybody by 2. That would work. This one means we'd have to divide everybody by negative 2. Also would work. Here, dividing by 2 would be yucky. Dividing by 3, that'd be yucky. So I'm definitely using the first one. You could use x or y, doesn't matter. I think I'm just going to stick with getting that x right there by itself. So let's rewrite this and move everybody around so that we can get x by itself. I'm going to add the 2y over. So we're going to get 2x equals, now remember those aren't like terms, so just 2y minus 4. But then we got to divide everybody by 2. So that's going to leave me with 1y minus 2. So that equation is the same as this first equation, it's just rearranged. We know that x is the same as y minus 2. So we're going to take this bit, y minus 2, since we know that's the same as x, and put it in here for x. So let's rewrite this equation, but instead of x, we're going to write y minus 2. Let's get rid of those grouping symbols. Distributing a negative, watch your signs there. A negative times a negative is a positive. I've got some like terms I could put together. They're on the same side, so we don't have to do the opposite or anything like that. We're just going to go ahead and put those together. Negative 2 plus 3 is 1y. Still have the 4 hanging out. To get y by itself, we're going to minus that 4 over to the other side, and we get y equals 2, which is great news. We just got to now go find x. Earlier, we said that x is equal to y minus 2. So now we're going to use this to solve for x. If x is equal to y minus 2, and we know from over here that y is equal to 2, we can put 2 in the spot of y and solve for x. So the coordinate point where these two lines cross is at 0, 2.